Perfect. Let's go back. All right. Thank you. So, we're good? Well, good afternoon, everyone. My name is Ismael. I'm one of the co-founders of Lagrange Labs. So people often ask me what Lagrange does. And the answer we give them is very simple. We're a ZK company. And the question people usually ask after that is, well, what do you do in ZK? Give me the niche specialty that your company does that solves a problem for one person. And the response that we give is, effectively, our company targets problems in zero knowledge, the largest problem sets that we can find, and commercializes those with some of the largest customers and counterparties in the industry. And so what that means is our research team publishes papers from everything on vector commitments to verifiable SQL design, to verifiable machine learning, to auction design for resource allocation and prover markets, all the way through to new snark constructions that have new PCSs that are fundamentally updatable. These papers are typically accepted in top conferences. We've had work in CCS, we've had work in FC, we've had work in Eurocrypt. And on top of that, we generate proofs, and we sell these proofs to many of our partners and customers within crypto. So it's a very simple business at the core, but what underlies it is a fundamental focus on research. So Lagrange is a research company. And so when we look at what we do as a product, it really is large-scale, highly performant, highly parallel, decentralized proving. We take the innovations in snark constructions, the innovations in proving systems that we build, innovations in mechanism design for prover markets that we build, and we apply them on top of our network to be able to deliver this to our counterparties. So why do you need decentralized proving, and why is it useful? This is a common question I've seen asked on Twitter. Well, the point of crypto is to build fault-tolerant, high liveness, and censorship-resistant systems, right? You can build a blockchain very easily that has no fault tolerance, that's a single node with a bunch of signers that submit signatures that are then aggregated by that node. But it has unlimited TPS in theory, but it has zero liveness guarantees because it's entirely predicated on a single node. And so we're talking about now building zero-knowledge systems fundamentally. And the same questions have to be asked. How do I build something that delivers zero-knowledge proofs for high-usage applications on chain that is decentralized? And so we have a network that's deployed in production today that delivers proof to this end. And so you can effectively think of it like an order book, a marketplace for the generation of zero-knowledge proofs that uses a double auction mechanism to match bidder price preferences and compute seller preferences. And so the core thesis that underlies this is that every app in crypto will at the limit become a ZK app. Every app on Ethereum, every app on an L2, every L2 in general will use zero knowledge at some point in its core design. And we're seeing this in the space. We're seeing optimistic rollups, Arbitrum, Optimism, start exploring moving to ZK stack. We're seeing messaging protocols. Layer 0 is a great example of this. Axtra is also a great example of this. Start exploring with using state proofs instead of economic-based guarantees. And we're seeing most DeFi apps begin exploring co-processing or other ways for reward and incentive issuance based on compute over historical on-chain data done in zero knowledge. And so we're starting to see every app start to adopt this paradigm of using some portion of its computation proven in ZK that's then verified back in the application on whatever execution layer it sits on. We're even seeing the execution layers themselves, like Ethereum's the primary example of that, start exploring moving to becoming ZK. So a core thesis of ours is that in the next 12 to 18 months, every app will be a ZK app. Some portion of its function will use zero knowledge. And what you require for that is a way that you can deliver those proofs that don't erode the liveness and censorship guarantees, the liveness and censorship-resistant guarantees of the base layer. And we get that through high-performance decentralized proving. And what makes Lagrange very special is how we architect our network. We like to design it to be as performant and modular as possible. So for example, we effectively take different types of domains for proof generation and we break those out into different subnetworks on our network. And we call these prover subnets. And so we have a group of, I would say, top institutional operators, folks like Coinbase, OKX, Kraken, P2P, who run provers for us within these different subnetworks. And it's based on a double auction model that our team put forward recently that was accepted into FC. That's actually the first paper that targets an incentive-compatible design for prover markets. And so it's effectively, you can think of this as a universal layer for proof generation that's able to segment out the types of proofs we generate into smaller submarkets. And each of those functions, you can think of it like a pair in a DEX, or you can think of it like an asset in an order book, wherein you can have a bidder express price preferences over what they want to pay for a proof, and a seller can express price preferences of what they want to sell their compute for. And the market itself has an asynchronous composition mechanism that matches bidder price preferences and seller preferences that's able to maximize the amount of proofs that the network's able to generate in a period of time. And then we can apply that across a series of domains that we generate proofs for. And this is in production today. As I mentioned, we have a very strong cohort of operators running this, and it's ever expanding. And so the way it kind of works is somewhat simple. There's an input gateway wherein if you want to generate a proof, you submit a request. The network takes that task. Provers bid on the completion of that task. The network itself verifies the eligibility of a bidder to be able to generate that proof based on hardware specifications, KYC specifications, staking specifications, however that sub-market has been designed. The proof is then generated. It has a time constraint over which it has to be generated. If it's generated within that constraint, the prover receives the payment from the network. If it's not, they receive a penalty either in the form of slashing or non-payment, depending on the configuration of the submarket. And why this is very performant and scales well? Well, if you think of kind of this monolithic prover network design that a lot of people are pitching right now, where you just have one ginormous prover network that does proving for everything, it's constrained by bandwidth. You can't just have a single orchestrator or gateway or whatever you want to call it that is receiving requests from many roll-up ecosystems, many L2 chains, base layers, apps, or even agents. So generally, what you want there is a way that you can segment bandwidth out into smaller markets. A very simple way to think of that is if you had an order book that just tried to jam everything into a single server. This doesn't make any sense. You need to have independent markets that can fluctuate. And so what we can do effectively is horizontally scale through this kind of modular architecture where we can deploy independent proving environments for different applications. We do this for major RAS providers, teams like AltLayer, Caldera. We do this for major roll-up teams like ZK Sync and some others that we'll be announcing very soon that we have some fantastic work that we're doing with. We do this for co-processing, where we work with teams like EtherFi, Gearbox, Azuki's, Frax, other large NFT and DeFi teams. And we will also soon be doing this for some interesting products that we're launching that touch on zkML. And so what this lets us do is to have very performant proof generation that runs in the network in a decentralized way. And I mentioned this a few times in passing, but kind of the core of this is what we call DARA, or double auctions for resource allocation. This is a paper that our team authored. It was accepted into Financial Cryptography 2025, which is a conference that kind of hybrids mechanism design and cryptographic techniques. And what this is a way to maximize, it's an incentive-compatible mechanism to support decentralized proof generation on a heterogeneous compute market. And so the way the paper works, it defines a set of properties under which a market is considered incentive compatible. It's very similar to, you can think of the work done on Ethereum's TFM by Tim Rothgarden and other folks. These properties are things like collusion resistance or group strategy proofness, welfare maximization, budget balancing, computational efficiency. And then we're able to formally prove that the mechanism that we propose is able to satisfy these properties. We're in fact the only network that's actually exists that has proof generation with effective market making and effective orchestration of a double auction mechanism or an order book. Now, why this is interesting is we're able to really support a very broad group of proving backends on our network that we're able to kind of leverage out for a lot of our partner applications. We do a lot of things with Plunky 3 and Plunky 2. Our coprocessor in-house, which is an SQL database that's, you can think of as verifiable SQL, is based on Plunky 2. We support modern ZK VMs, we support Leiden VM, and we support some stuff that's GKR and some check based for our ZKML provers, which will be coming out soon. And we generally support proof generations for most major stacks as well, including ZK Stack, Hermes Stack, and some other ones that we're excited to announce soon as well. And now, a little bit of a case study. We announced some great work earlier this year with ZK Sync, a close partner of ours and a company we think very highly of. It was sort of the industry's first example of decentralized proving for a ZK rollup stack, where we were able to kind of connect to their system and have a large group of external operators contribute to generating proofs for ZK Stack chains. The really good finding on this is we're able to source compute for about a third of the cost of what you would be able to do on G-Cloud on our network. And we also have equivalent proof generation time to what you'd be able to see in a centralized system within an order of magnitude. And so that's, we think this is a fantastic finding to kind of start proving out the reasons why decentralized proof generation makes a lot of sense for crypto in general. And really credit to a great group of institutional operators who supported us very early in this work stream, including P2P, Nethermind, Blacksand, Eigenyields, and Kraken's proving arm, or Kraken's staking arm staked. And yeah, so we think there's going to be a lot more announcements coming out kind of around decentralized proving for major roll-up stacks in this coming months. And so what's next for Lagrange? I mentioned that we have some great stuff coming with roll-up teams. We also have some products coming very soon that I can't share full details on, but it's effectively ZK for AI and machine learning applications. And from our early benchmarks, they're about 1 to 2 orders of magnitude more performant than any open source technology available today that's doing this, which we think is a very good early finding, where we start seeing potentially Onyx file models start now being provable in some low constant with respect to computational overhead. And we also have some great work coming with DeFi NFT projects that we work very closely with on coprocessors. We're kind of entering this wave in crypto that I'm personally very excited about, where a lot of DeFi protocols are building some new mechanisms that were otherwise not possible with the current technology of the previous cycle. Examples of that are like under-collateralized lending, on-chain credit history, continuous incentives. So teams like Royco are doing great work on Berachain and Movement with this. And as you start seeing more and more assets issued under these kind of new mechanisms, you start needing to build more performant and more secure versions of this, right? It's very hard to issue, $1 billion on a centralized mechanism that's distributing rewards on chain by a Merkle root, right? At some point you say, okay, if I have to post this root every day and the risk of this being compromised is $1 billion, we need to move this into ZK so that we can prove a user's eligibility for these rewards with a higher degree of security guarantees. And so there's some great work that's coming out there that our business development team and our engineering team have been spearheading. And yeah, so what we like to end with is really prove anything with Lagrange. There's so many applications of ZK in crypto, and any of those can run on top of our network, on top of a very robust, censorship-resistant, and decentralized architecture that has an incentive-compatible mechanism for work assignment. There's top teams in the space doing this already, and I expect this graph to get even larger in the coming weeks and coming months. So reach out to me if you're building anything cool that uses ZK, or if you're building anything that you think could use ZK. We're doing a lot of work now exploring AI agents and kind of AIX crypto in general, where we think there's some really good opportunities for the application of ZK. All right, that's the presentation. Any questions, guys? Yeah?
Yeah, I'm here speak for the one of elastic chains on ZK Sync. So
Which elastic chain?
ETHZK.
Very cool.
Sorry?
I said, which one?
ETHZK.
Oh, cool.
So my question is, about decentralized provers
Yeah.
and proving marketplace.
Yes.
So, very dumb question. Can you just can we just double click on that section and can you a bit broadly explain how it works? For example, if you go back to the slide where you
Yes.
no, not that one. Earlier. One more. That one. For example, prover beats.
So, quick question: do you run? Is it self-hosted? Is it IRAS or is it?
It's self-hosted. We run our own provers.
Perfect.
Yeah, and the question is how is decentralized what is decentralized marketplace?
Yeah.
What are the mechanics? How they work? For example, if we talk about that
Mhm.
scheme, for me it's unclear what means prover beats on new proven tasks. So, for example, we as a self-hosted.
Yeah. So let's go from the sequencer. So a new batch, I think is the best way. Yeah. So you have a new batch of transactions, right? That gets posted, or that gets written to you. And so you have a batch that you're going to commit. And so then you request from us a proof of the execution of that batch. We take, in essence, the jobs that are used within ZK Sync's internal current prover, Boojum, and we turn those into tasks on our network. And then our network independently auctions off those tasks and handles both the recursion back together and the generation of the final compressed proof. So we run the compressor as well on our network. And then what you get back is the final proof you can submit on chain.
But how it works in the context of decentralized provers? Because I assume that
Mhm.
we run our proving infrastructure for our Elastic chain.
Yeah.
And since it's a decentralized, you can also compete for the tasks of our provers on the marketplace.
Yeah. So
Is it the right thing is it the right way to think about it? Because now, for example, in the ZK Sync
yeah.
example, they are now there is a proposal about ZK Gateway, which
But ZK Gateway's verification.
what?
Gateway's verification, right? ZK Gateway's verification.
ZK Gateway, yeah.
That's verification.
And Gateway will, from my understanding, will orchestrate
Mhm.
the proofs of all Elastic chains.
It orchestrates the verification of proofs. It doesn't orchestrate the generation.
And
This is about generation, yeah.
so the marketplace is about generation.
Yes, this is just generation.
So we compete for generation, and we.
So you don't have to compete because you are the Elastic chain. So you basically submit a task, right? And the input that you'd submit is effectively the batch of transactions that you want to prove. That we would get from a connection to your sequencer database. You could just basically send us in a specific format the data that we would need to understand through this proof generation. Our system handles taking that and breaking that up into the work that would be assigned over our network. We assign that work out over our network. We generate those proofs. We recursively combine them back together. And there's multiple rounds of this because ZK Sync's prover handles multiple rounds of proving right now. And then we generate the compressor proof at the end of that, and we return that back, which can be submitted on chain or can be submitted to the gateway.
Okay, but it sounds like you still describe a centralized scenario.
No, because
you describe it from
the prover's bid.
What?
So you request the generation of a proof, and the prover's bid to do that. So our network bids to do that.
By saying provers, what do you mean? So
Oh, provers, like
there is a provers.
no, these are like Coinbase, Blacksand, Intstones, OKX, Kraken,
Yeah.
P2P validator, Luga nodes, Blockdaemon, Anchor. These are like big companies.
Okay.
And they each run a prover or a series of provers, and they bid to generate proofs in what you can think of like an auction, right? It's an order book. So they basically say, I'll generate a proof for like this subsection of work at a cost of X, and you obviously will want to price as low as possible to drop the cost as low as possible, and we're able to generate that at a substantially lower cost basis generally. Or the network's able, not we, but the network.
And who arbitrates which prover task will be chosen? So since we have multiple provers and they bid for task, so it's an auction that let's say Coinbase says I will take the task for $1
Yeah.
The other, like OKX says, I will pick the task for 98 cents. So OKX will pick the task for.
Unless someone else bids less than 98 cents, but
Unless someone.
yes, but if they bid 98 cents, they take the task for 98 cents. And then they generate that proof in a period of time. So you can think of this very much like an order book, right? Because in an order book, you express a bid and someone is an ask, right? And so there's an ask that they want to receive on the compute, and a bid that you're making for the compute. And then there's a mechanism, which you can think of it as a composition mechanism of how we're able to settle the bid and ask spread. And then we handle services that effectively do market making between that allow it to be much easier for bidders to understand what to bid and sellers to understand what they should express as the cost of compute. It's very similar to how, like, in any effective market, you need an entity or a group of entities that can help close the bid-ask spread by expressing the relevant kind of benchmarks on cost.
Okay, and after that,
Mhm.
what are the incentive for you as a network provider and
Yeah.
for the provers and for other prover networks that compete for the task? What are incentives for?
Yeah, so the provers who compete to generate proofs, they bid generally the cost of generating that proof plus a margin, right? And the margin being what they will take in internally. So let's say I run hardware that I can generate the proof on AWS or on Google Cloud for $1, and my system can generate it if I run dedicated instances for 30 cents. I will bid 40 cents, right, for example. And then you save 60 cents, I make 10 cents, my costs are 30 cents. And so you can think of how the market's formed very similar to that, right? Where effectively the bid that a rational actor would make would be cost plus margin.
Okay. And can we now double click on the async slide here?
Yeah.
So since there's not much information.
We have a bunch of public stuff on it.
If you can disclose how you can participate in the decentralized pro marketplace roadmap of zk-Sync, you will be one of the providers? Or?
We have yet to announce the full details, but we can talk more after.
Okay, for sure.
Mm-hmm. But effectively, what this is, for the clarity in the cameras, is a network that we launched with the support of zk-Sync. It's a test network where we proved several batches for the Elastic chain or for zk-Sync Era in a decentralized manner, and an announcement that we did that our network supports that. Their team was very helpful in the development and the launch of this.
Okay, I will keep my other questions.
Yeah.
For after the Q&A.
Perfect. Yeah.
I have a question regarding the pricing,
Yeah.
the auction bid mechanism.
Yeah.
Have you considered adding from the buyer side potentially another parameter?
Well, it's a double auction.
Latency?
Pardon?
Target latency?
Um,
As a feedback loop so that the provers can optimize. Because I remember the other side bias where you said like it's different for DeFi applications. You want to split that up from rollups.
yeah.
But there has to that in the future there should be a feedback loop so that the provers get the information of what actually the buyers want, and it's not necessarily what is, in my opinion, cost. Sometimes
Yeah.
cost can be higher, just latency has to decrease.
Yeah, so the market it allows you to express preferences over latency. Yeah, that is true. You're able to express preferences over proof generation time. The composition rule is based on matching price preferences of bidders and sellers, right? Because the composition rule doesn't have a guarantee over latency, right? Because you're effectively saying I'll take anyone who generates this proof in this time constraint, and then people bid on the generation of a proof in a time constraint.
Maybe as a feedback loop
Yeah.
for like the future when you have like more provers, I would say that it could be potentially beneficial, right? Like I'm gonna pay if you can prove in like let's say 30 seconds.
Yeah.
But I want 15 seconds. So if someone comes in and does 15 seconds in the future, because that's like exponential.
Yeah, so you can say, so you basically say how long you want. You say, I want this proof generated in 30 seconds, and people bid to generate. If you say I want this proof generated in 15 seconds, people will bid to do that as well, right?
Or maybe they won't bid because they can't.
Yeah, or if you say I want it 1 second, they can't do it, then they won't.
I'm just
They won't bid.
like more like future feedback.
Yeah.
so they know which way to develop.
Well, there's a natural pressure on the market to decrease proving time, right? Because the lower your proving time is, generally the lower the cost is, right? Because there's fewer CPU seconds or GPU seconds that you're using. Yeah.
So I think just rephrasing his
Yeah,
question
yeah, yeah.
about decentralization.
Mhm.
So you have double auction mechanism.
Yeah.
But, I'm thinking it is like a, let's say, a double auction for certain large beefy people, and suppose a new small homestaker, like
Mhm.
Ethereum homestaker, wants to be the part of the system.
To run a prover or to
To prove it.
request a proof?
To run.
I'm talking about.
Yeah.
I'm talking about the
Yeah.
Yeah.
the validator equivalent of. The
Yeah,
Yes.
yeah, that's exactly
Oh,
what I wanted
anyone
to
can run it.
say.
Anyone can run it. Yeah. You just sign up. You just sign up. Yeah.
Yeah. So I want to, but I don't have such a high beefy machine.
Yeah.
I'm losing by 1% of a margin of Coinbase
Mhm.
beefy server, right? Because maybe Coinbase is subsidizing it by something else. So
Mhm.
it's a way of
Yeah.
decentralization versus centralization, and there is also in economics in this double auction equilibrium is in a long-term equilibrium is gonna be monopoly.
No, it wouldn't be a monopoly, right? Because compute's not a monopoly.
Mm,
I mean, compute's a commodity, so functionally you have access to compute at a very similar cost to any other entity.
yeah. So
I mean, sure, there's economies of scale in
Yeah,
compute, but
so
it would more likely be that these markets converge to oligopolies.
So I'll give you one more example. Like I think, like let's say you are running an Uber network, right? We all
Yeah.
know Uber matching market, right?
Yeah.
But the Uber, every driver has a chance. Let's say a homestaker or maybe running a fleet of cars, because Uber has a centralized pricing mechanism. So
Mhm.
that's an equivalence here.
Well, Uber sets pricing, right?
Sorry.
Uber sets pricing. Uber's not a
Yeah,
market,
centralized
right?
pricing, the Uber
Yeah,
sets pricing.
yeah,
But
it-
what you are saying in here is that it's a double auction mechanism. Anybody can outbid anyone. So
Yeah.
to take it in the Uber market, like imagine a scenario in which now drivers can outbid, right, each other.
Well, I mean, effectively, you can go and generate a proof with any type of constraint that you want on proof generation, right? So if you would like to generate the proof at the same, if you no longer want to be outbid by Coinbase, for example, you can just drop the cost that you're charging, right?
Yeah, but suppose so there is
So I mean, like, there's nothing that prohibits you from doing that.
no. So that's
Yeah.
That's a point I'm trying to understand.
Yeah.
Because
So
look,
yeah, you set the cost that you want to generate proof for. So if you want to say, I want to generate that proof for free, like nothing precludes you from doing that.
suppose I'm like in a homestaker kind of a
Yeah.
situation in a decentralization matrix, right?
Right.
And a company like or a protocol
Yeah.
like ZK Sync wants a decentralization up to the limit of homestaker proving.
Right, but these aren't stakers. So the reason a validator set benefits from having a large distributed group is because they're all re-executing something. The way ZK works is that you only need one party to generate that proof, and you need, in the event that the single party generating that proof fails, there to be fallbacks. And so as long as you have a sufficiently large number of actors who are able to generate a proof profitably in the marketplace, it is decentralized, right? So saying like you want a guy in his house in Argentina to be able to generate a proof, like that doesn't make it plausibly more decentralized. It just makes it more inefficient.
Yeah.
You need 5, 10 actors who have the capacity to generate a proof, such that if 1, 2, 3, 4, 5 fail, you have fallbacks that the network can fall on. You don't need 10,000 people to sign something like Ethereum, where you want, someone in their basement in Argentina who's hard to corrupt.
Yeah. So I think that's like the fundamentally what
Yeah.
you are trying to say, the efficiency versus decentralization.
Well, no. So I'm saying that decentralizing a validator set is fundamentally a different problem set than decentralizing a prover set. And you're trying to impose a constraint that you would look at on decentralizing a validator set on decentralizing a prover set where it doesn't apply. That's what I'm saying.
Okay, so the minimum, like what the fundamental assumption is that you will have more than one large provers in the system.
Yes, you will have more than one. You have
That's
85 right now who can compete on pricing.
exactly, and in the long run equilibrium, we are pretty much certain there is not going to be one person who is going to monopolize. In long
No,
run,
if you look at compute markets, It's even GPU training. There's not a single entity who owns all the GPUs, right? There is a series of entities that own a large number of GPUs, but markets like Prime Intellect, for example, that sell GPU compute. There's a series of people who have sufficient latent compute capacity at a price point that's competitive. And we see this with all compute markets broadly, right? It's a commodity market. You actually don't see open commodity markets ever become monopolized if you have open and free competitive market practices. The only places you actually do see them become commoditized is if you have like regulatory capture, right? Like Standard Oil in the 20s, or sorry, in the early 19th century. Late 19th century. But if you look at like international oil markets, look at OPEC countries, look at any of the super majors, there's a reason why commodity markets don't become monopolized, they become oligopolies. And we'll likely see the same thing here.
Yeah. But we can discuss later, of course.
Yeah.
There's. I would like to post one more example about high frequency trading, right?
Yeah.
And in the race to bottom,
Yeah.
there's been ample research going on because you've mentioned order book and spread size, right? That it leads to monopolistic or
Not monopolistic. There's not a single order book that's monopolized by a single HFT. You have multiple. You have order books that have a small subset of HFTs, right? You'll have 5, 10.
That there has to be 3 to 4 people. So regulation is actually guarding against monopolistic power. So in the market, there has to be more than 3 to 5 market.
I'd want a citation that Binance has a requirement, or OKX has a requirement that there's 3 to 5.
I'm talking about the traditional financial market like Citadels and jump trading of the world, of course. Like
So the New York Stock Exchange. Right?
Yeah, but like I'm talking about the market makers.
Yeah,
the
so-
HFT firms.
Yeah, so I mean, you have multiple HFT firms that can compete on any order book.
Yeah, because they're required to compete.
Not on every order book. You have plenty of order books that exist that have no requirement over the plurality of actors, right? Because you have multiple people who have relatively equivalent competitive capacity, right? They have similar compute, they have similar smart people, they have similar infrastructure, so they all can compete.
Yeah, but compute, anyways.
And by the way, compute's a commodity market, right?
Yeah.
And you can't name for me, I would assume, a single commodity market that is monopolized without regulation requiring monopoly.
It's the inverse, which is true. So the compute requires capital to build the compute, right?
Capital is also not centralized
And the capital.
or monopolistic.
Yeah. So and the capital, if you have a sufficiently high capital, you can keep on subsidizing the proof until there is no competition in the market. You see?
When competition comes back, we saw OPEC try this over and over again, and you saw peak production in Canada compete with it. Because if you try to raise prices on something, or drop costs, and then raise prices later, there will always be new entrants willing to undercut you because there's an incentive to do so.
No, but you're right. Like the fundamental assumption is.
Well, the fundamental assumption is that's an efficient market,
Yeah, efficient market.
which is what we build.
The new the new entrant have only compute to provide. Like if you kick out the new entrant and such subsidizing costs, they might do something else. They might build.
Until the margins come back, and then they come back because of the incentive to make money. There's very few places, and actually I can't think of a single place in the world where you can make money that people don't go and try to make money. We continually see this in every commodity market.
So in the compute market, if you look at the market structure of Web2 from.
Let's talk GPUs.
Yeah,
Who are the major GPU sellers?
AWS,
Is it centralized? Is there one?
AWS, Google, and Azure, right?
Yeah.
There is a reason why.
And then a
it's
bunch
run
on
by,
Prime Intellect.
The big companies.
But that's not a monopoly, that's an oligopoly.
Yeah, that's an.
And then you have a whole spectrum of long tail providers.
Oligo.
All the dedicated providers. Oligopolies and monopolies are very different structures,
Yeah,
right?
I know.
An auction is efficient, which is more than one participant.
Yeah. Anyways, so my point was to have like the decentralization efficiency, and of course.
And then we go back to my principal point that the metric with which you assess decentralization by in a prover market, which has a 1 of n assumption on proof generation, is fundamentally dissimilar from the mechanism that you would assess decentralization by in a validator that is a k of n assumption.
No, but like I'm
where K is greater, is roughly 2/3 of N.
I'm abstracting away from whether you are building a prover network or you are building like a generation of a wheat production, right? Or a logistic or a Uber or like it's a general.
But markets are different, right? So, sorry, not markets are different, but the security requirements over decentralization across both of the aforementioned network structures are different. So comparing the centralization of a validator set to the centralization of a market is very different. A validator set's actually not a market, or it's not an order book. It's a market of a different structure. Because by definition, Ethereum's consensus, every single validator gets to sign. By definition, or at least the plurality of validators get to sign. By definition, in an oil market, not everyone gets to produce oil. Not everybody gets to sell oil.
But
yeah.
Do you mind if I interject?
Let's interject,
so,
yeah.
I don't know if I missed it, but do you mind running through the double auction, the whole mechanism?
I don't have the whole mechanism on the slide here.
So I'd assume it's pretty much
I can send you the paper. It's a double auction that's based on a composition mechanism that our team has. So the difference between an order book and a double auction would be the time frame, so it's a discrete.
The time dimension in terms of when the buyer makes an offer.
Yes, there is.
It's there definitely should be constraints in terms of how fast you want, and I guess
exactly.
That end there could potentially be some market forces where there's a big kind of setup operator versus like the small home style operators who could actually get the work done within 2 seconds or not. If that makes sense.
Yeah, it does make sense. Yeah.
So there's that time component, I guess, when the buyers or the operators kind of making the offers. Right?
Yeah, the main difference between an open order book and this type of double auction mechanism is that an order book is a continuous double auction, right? So you effectively never have an end to the process of bidding and expressing price preferences over resources. The difference on this is you have effectively rounds of the double auction and the composition mechanism that runs within each round.
How long are each of the rounds?
It's configurable. The paper has proofs on a lot of these properties. Yeah.
Just interested to hear, where do you see the majority of the demand coming over, like, let's say, next 12 months?
Yeah, so that's a good question. So there's one market in crypto for proof generation, and there's a bunch of like smoke and mirrors that teams are trying to throw up, but there's like one thing that people are paying for proofs right now, and that's rollups. And that's probably where you're going to see in 12 months. Where you're going to see in 24 months is likely other places where people are willing to pay for reduced security assumptions on compute that's used on chain. And so where do you see that? You see that with agents. You see that with a lot of the ZKML protocols, decentralized training, decentralized inference, where you can start putting in zero knowledge guarantees, right? And so if the overhead on decentralized training is less than the overhead on replicating that training across a validator set, it now becomes cheaper to start moving that onto a decentralized, onto a proof generation. Same as inference and agents and anything that uses a consensus that replicates an expensive computation.
Maybe another question.
Yeah.
What type of efficiency gain do you see by fragmenting the markets into like the specific use cases that you mentioned?
Yeah, it's much more efficient on proof generation because you're able to have each market independently run asynchronously. And so you don't require some giant global auction that matches every private proof being generated for every type of application. So there's no constraint, for example, on ZK stack proof generation because there's a burst in AI agent proof generation. So you can keep these things running separate.
So it's
more an efficiency gain on the auction side.
Exactly.
And do you see efficiency gains by like someone is specializing for something that DeFi protocols need, someone is specializing on agents?
If you're specializing in proof systems, for sure. So like let's say you have a more performant way that you're going to accelerate Plonky 3 at the Fabric's VPU chip. Then all of a sudden you have a competitive advantage on generation, and you have to then have other people buy that chip and other people start building libraries accordingly. You have the same things on GPUs, you have the same things in a lot of places in markets. So you do have an incentive to decrease cost over time.
Just to comment, in the long run, what I was trying to say, and not to say the validator part, in the long run, what I suspect is that you have improvers, right? 4 ticks each. There will be only one.
No, you're not going to. You're not going to. You don't see this in other markets. I mean, it's.
Or maybe 3 oligopoly
You might have 5, you might have 6, you might have then a long tail of randos who get one proof every so often. That's probably what you'll see. Yeah, that's very normal, right? You see data centers have economies of scale over compute. And so we're going to see oligopolies of data centers. You're not going to see one entity own all of the data centers in the world. That would be, I mean, infeasible. It would be comical. But you're going to see 5, 10, 20 people who have the performance requirements to generate these proofs. And if one of them falls out, if they're no longer able to do that, then you're going to have competitive participants take up the slack, as you see in any market, right?
Oligopoly is very valid in terms of.
That's what commodity markets generally are.
Yeah, and then the decentralization concerned with oligopoly is perfectly fine for ZK Sync as a rollup.
So once again, we go back to the same question of when you're assessing decentralization or the degree of decentralization for proof generation, it's a different question than assessing the degree of decentralization for validator sets. Because a validator set requires the plurality of those validators to sign something. A decentralized proof generation requires one of these people to do something. So you need an amount of decentralization such that if that one, who's the most performant and most cheap, goes down, the remainder can pick up the slack. It's a very different structure, right?
Yeah.
Yes.
I think you did mention something about each of the prover kind of sub-networks being isolated.
Yes.
So, but I'd assume, like, under the hood, it would be something similar to, like, the Avalanche kind of sub-network. So, if there is one spike in a specific use case or specific, it should definitely impact, I guess, in some way or the other, like how the performance should be or what the availabilities would be with the other sub-networks.
It shouldn't, because in theory, you can run a subnetwork if you want, right? You can spin up your own subnetwork, and you can say, I want to do proving for some domain that's interesting to me, and you can run the infrastructure. And if my subnetwork has a high amount of traffic and yours doesn't, it doesn't create necessarily issues. Or I think the best comparable will be rollups, right?
This is how elastic chain networks.
Exactly.
Each rollup is basically a subnet, and each rollup runs
Exactly.
its own self-hosted proven infrastructure or relies on a RAS provider.
Exactly.
By the way, can I ask a question?
Sure, go ahead.
I want to relax the topic of authorization. So we're talking the division of proof generation based on use cases. So the most obvious for now is rollups. We generate proofs to synchronize state of L2 with L1. Just for our overall awareness, can you make some examples of other use cases? Where, for example, you say DeFi protocol. What kind of use case here for proof generation?
So I'll give you a couple concrete examples. EtherFi, they're a very large LRT protocol, which they're building a credit or debit card. Sorry, it's a credit card. As you spend a credit card, it basically takes a loan against your balance. You deposit in EtherFi, lets you transact. Well, what's an integral component of a credit card? Cashback. And so what they want is as you spend, they're able to, in real time, prove the amount of cashback that you've accrued so that you can withdraw that cashback whenever you want. And so what you need is a proof of a computation over historical data on-chain that validates against the block header you want to redeem your money from that says you've spent X over some period of time. And that's a compute over the historical data of a blockchain. And the only way to succinctly do that, because you can't do that in the execution environment, would be to use a zero-knowledge proof. And so we offer a product called a ZK coprocessor that allows you to write SQL computation over historical blockchain data. And so EtherFi is one of our partners on that. We also work with Frax, another DeFi protocol. An example also would be Azuki's. They're an NFT company. They want to build incentives for their L2 and then as well for kind of reward issuance and badges of how they incentivize you to hold the Azuki's for a period of time. That requires compute over historical data, and that requires a proof of the correctness of that computation if they want the reward to be trustlessly issued.
Okay, and let's say we take an example of EtherFi, where you use the card to pay, to take a loan against the balance and acquire cashback. So what? Basically what we do with proving, we prove the state synchronization of your balance with the protocol. Yeah?
No. So every time you transact with the card,
let's say I have $1,000 on EtherFi.
yes.
I claim the credit let's say I have
So it's like, yeah,
yeah, $500 available. So each time I pay,
they submit a transaction on chain.
I submit the transaction.
They
chain.
submit, yeah.
Yeah, they submit transaction chain.
Visa.
So they basically take $10 of my 1,000 and spend it.
Or they effectively would determine that they'd put a transaction on chain that tells the amount that you've spent, and they would update a counter of how much you have against your position.
On which type of data we generate the proof?
Transaction data. So it would be the accumulated amount, the receipt data, because it would emit an event every time that you had that transaction. And you would compute over the receipt data the amount of aggregate spend that you had times some constant, which is your cashback rate. And depending on the tier you had of the card at the point that you had that, there'd be likely a storage slot that would say cashback tier.
Okay, and what happens if I let's say bought something and then I refunded my purchase?
Well, then it would submit a transaction batch back.
I submit
So
I, on behalf of my account, submit transaction.
Visa has a connection with EtherFi,
Okay.
and both of them handle submission on chain at the point of transaction. I believe that's how their flow works.
So basically, what we do with ZK proven is we synchronize three states: the user balance.
Less synchronized. You more just compute over the historical state, and the public input to the proof is the block header in question at the point that the proof wants to be verified.
By synchronization, I mean that we prove and verify
Mhm.
that the activity of the client, of the protocol, and the chain
Mhm.
are verified.
Yes, so effectively you verify that there's the result of some computation over some subset of historical receipts, transactions, or storage slots.
And what if we imagine that we do not use ZK proven for that use case? How will be this use case? How this use case will look like in opposite way?
I could store every transaction in a mapping,
It has to store every transaction on the database.
in a mapping on chain. And you would have to store in the mapping so that when you redeem, it's expensive.
So correct me if I'm wrong,
Yeah.
if I understand right.
Mhm.
So by using ZK proven, we abstract abstract extra expenses for infrastructure. So we no longer need a database that will.
No. It's less about a database, right? Because at the point that you want to take your cash back, the contract that's issuing the asset back to you needs to determine the amount of cash back you are owed. And so if you do it off chain and there's nothing back, and I just say, hey, I want $50. Well, I want $1,000. I want $1 million. I want $1 billion, right? I could say any number I wanted. So the contract itself has to know the amount of cash back that you're due to be issued based on your purchase history. And so you could store the purchase.
And the purchase,
Yeah.
And the purchase history is submitted to that contract as a call data compressed with ZK.
No, it's not submitted. So every time you transact, there's an event, basically, right? It's a transaction on chain and emits an event saying you spent $50 at Starbucks or you spent $10, at CVS. And then whenever you want to get your cash back, you generate a proof of, okay, look at all the events that were emitted by your address over some period of time, or attributed to your address for some period of time, your card over some period of time, and then generate the sum of the amount that you've spent minus the sum of the amount that was, that was reimbursed. And then that's the amount that you're owed times some constant. That's the amount that you spent times some constant, which is cashback rate, and then you get your reward. And the contract itself can determine that that's correct because the input to the proof is just a block header of the chain at the point you requested the proof. So basically it verifies against the root of the chain. Because you can think of all the data in the blockchain as one giant unbalanced tree, right? Where every block is linked to the last block, every block has a bunch of trees, and so you can generate a batch proof of inclusion of all the relevant subsets of the data, and then do a computation of that subset. It's a very, very complex proof to generate.
So does it mean that without ZK proven mechanism on top of that, it is either resource intensive or impossible?
It would require you to store every transaction in a mapping on chain and then try to iterate through those, or it would accumulate some data in a weird way. It just wouldn't be very cost effective, to your point. What everyone actually would practically do is just centralize it, which is, hey, when you want cash back, I'm just gonna, on my back-end server, say, hey, I'm company X, and so you deserve cash back of some amount. I'm just gonna do it myself and tell you that and give you your cash back on chain. So the apps lose the security property of the chain the more components of them that you predicate on a centralized actor off-chain. And that's why, when you start talking about larger balances of rewards and incentives being issued, you require that there's a higher degree of security over how the computation on-chain is derived.
Okay.
Yeah.
Is there any penalty mechanism for not delivering a proof on time?
Yep.
At all?
Yeah. You get either slashed or not paid depending on the configuration.
You stake it. Okay.
Or you just there's a time value to any capital that you hold and a time value to the compute you expend on it.
By the way, good question about slashing.
Yeah.
And what stake do you slash?
It's complex.
What?
It's complex. It's configurable.
And what is the transaction fee numeric, like currency?
For staking?
No. So for the network to run, like suppose I'm an elastic chain, so I send some money. Is it in dollars or is it in tokens?
It's whatever you want. Well, sorry, it's either USD or ETH. But like, yeah, it's USD or ETH.
It will be proof of authority, I believe. So
Mm.
you stake some kind of tokens?
I can't talk about the Elastic Chain's vision for how they want to do stuff on their side. I am not in a position to talk about that.
But the Lagrange, the network.
But for how you pay our network, it would be either USDC or ETH.
You stake either USDC or
No. You stake. What you stake depends on the gateway. The gateway can decide what you stake. So in theory, you can have a gateway that stakes ZK. You can have a gateway that stakes Lagrange. You can have a gateway that stakes Polygon. You can have a gateway that stakes really any asset you want. For a given network, it just depends on the relationship that we have with whoever's generally originating the demand, right? So for example, let's say you have a giant amount of proofs you need per year, and you're like, hey, I got a ton of proofs I need per year. I want this to be done on this network, and I want there to be a stake in your own token. Well, that's a conversation we can have. We can also have the same conversations for payment mechanisms. As long as the provers get paid, the provers can opt into each subnetwork that they want. There's no mandate, right?
So the design is that we can decide what type of asset we stake and what type of asset we use for rewards. Yeah?
For payments, yes, but the constraint is that a prover has to be comfortable with it. So if you're a long-tail token, you should probably not do that because provers are just not going to do that, right? Like Coinbase is not.
You mean Coinbase and
Yes.
it will be validated.
Yeah, they're not going to.
Comfortable.
Yes, they have to be comfortable.
How much and how does is the contract which is being made or is it like on chain?
It's on chain, yeah.
Yeah. So it's like a auction in it itself.
We use Eigenlayer for staking and payment flows.
ADS or what?
Yeah, so you can think of each of these as like a little ABS kind of thing. So you can stake into Eigenlayer, you can put your asset however you want. They handle payment flows and staking contracts.
Nice.
Yeah.
Just wanted to double check on going back to the sub-networks page.
Yeah.
So as an operator, does that mean that you have to be dedicated to a specific gateway, or
No, you can be, you can be of KVN, however many you want.
so you can be generating proofs from multiple gateways,
Yeah.
multiple markets,
Yeah.
multiple isolated markets. But
Yeah.
I guess that does raise the whole question of like these markets are not 100% isolated in the sense that like each of the operators are interdependent in terms of their availabilities.
But in theory, but once again, you're considering like a nearly unbounded commodity of compute, right? And so there's so much compute available. The idea that like if there's a spike in compute somewhere else, there's not sufficient compute somewhere else to take it out, right? Like if there's a spike of computation on Amazon, right, on your dedicated area, it's in theory should not harm Netflix. In theory, at the limit, you can think of Netflix maybe crashing Amazon, but there's a.
So assuming that all the operators is a very like competitive operator market that
Mhm.
like wherever there's a spike, all the other like idling resources are pretty much rerouted to that specific market.
Well, markets would generally like if there's a spike somewhere that's sucking a bunch of compute, it really doesn't take much to add more instances somewhere else if you or someone servicing that market. Like load balancing of a centralized prover, which is what every prover is, right? The market's decentralized, and the individual prover is centralized, right? an individual Ethereum node is centralized, Ethereum as a whole is decentralized. So load balancing one of those is really not hard.
So I think like where I'm
Yeah.
point I'm trying to make sense is, as opposed to monolithic market structure.
Yes.
We're pretty much broken down into 5 in this.
Well, it's
picture,
way
right?
more than 5 in
Oh,
theory.
so
It's going to be,
markets,
but it
then
couldn't fit all of them on the
it
screen.
actually opens up much more opportunities for arbitrage, if that makes sense. And if there's one spike, as opposed to if there was one market,
Mhm.
like the price would actually act more as a good settlement, or the pendulum between the supply and demand. Whereas like here, if there's one spike in one market, we would have to depend on arbitrageurs between markets to actually fill up the space.
It would be less about arbitrageurs, right? Because if you have a spike in, because you have different compute requirements on different markets, right? Like you have different requirements to generate like a zk stack proof versus a, let's say you're doing.
So my assumption is, and you just confirmed it, that even though you have a broader cluster of prover circuits, the gateways of the subnets will have different requirements.
Exactly.
Because even zk stack, they has some kind of tiny circuit prover client that they need to install in order to generate proofs. And I don't know, and I assume that there won't be much opportunities when you like run the whole cluster and you, for example, generate proofs for L2s, and then you see very short-term spike on, let's say, NFTs, and I do not think you will be able to rapidly switch back.
You're not going to see, once again, so if NFTs spike, the cost of an NFT proof goes up, right?
Yeah.
And so someone who's running infrastructure for an L2 chain, they're probably, so the question originally was if NFTs spike, would that harm the bandwidth of like a zk stack chain? And the answer is strictly no, because you use different proofers, right? So you have entirely different instance types across those two things. What would be a closer question would be if you had one gateway doing a bunch of proofs for you, and then a bunch of proofs for Caldera on the exact same instances on the exact same stack, then there might be a broader overlap. But like generally speaking, the market as a whole, like most of these sub-markets are going to have different infrastructure requirements.
But they have to do, right? Because the objective function of the provers are to maximize the utilization of their AWS hired servers, right?
Well, you can reach max utilization on a single market, right? You just bid competitively.
And it's not difficult to reach the max efficiency.
No, it isn't. These instances run. There's a lot. Yeah, there's a lot of compute that's needed. This is yeah. No, on our test, we were at max efficiency on all of these provers. We needed, in fact, more proving. But, because we were covering a lot of this stuff out of pocket, we did not want to add all these people back in. So the test with those 5 provers, they were at capacity the whole time. It was like not really a concern. Once again, right? What happens when demand goes up for proofs? Well, cost goes up.
Yes.
And so more people are now willing to do this, and cost goes back down. Now you can charge a 20% margin, 30% margin, 40% margin, 100% margin, and then someone else comes in and goes, hang on, wait, I can charge a 90% margin on my AWS instance, and someone else, I can charge an 80% margin, and it goes back down. That's why markets are beautiful.
Well, I guess the exact fact that there are different configurabilities introduces the whole certain barriers for market balance, certain choke points, I assume. Like that one operator who has been providing proofs to a specific gateway cannot easily or interoperably kind of provide the proofs to other markets or other gateways.
Well, they would require different proving infrastructure. This is a constraint of ZK and not a constraint of this, right? So, like, to do a proof for Plonky 3 on a VPU chip that Fabric wrote a kernel for Plonky 3 acceleration, it's an entirely separate instance than doing a proof on a GPU for the Elastic chain versus a CPU for Hermes. Like they're fundamentally different instances, and so you can't reconfigure your VPU to do proving that's designed for CPU,
Of course.
irrespective if it's one market or many markets. The main thing here is that, like in practice, the constraint is going to be on the auction, right? Because if I'm trying to match 40,000 proof requesters and 40,000 bidders, there's latency on all of that stuff. There's latency that you face on having a single centralized system if you're trying to centralize everything into one market that you don't face by having this kind of a much more fluid and elastic structure.
Well, speaking of the commodities markets, I mean, even like 3-4 months ago, there was a huge imbalance in price between copper price in LME and copper price in CME, coming from these certain barriers between price imbalances, and especially geographical arbitrage opportunities. I guess
It's interesting. I didn't know that.
Oh, I didn't know that.
Are these different markets? So is there like regulatory reasons you can't trade on one or the other, or why?
It's mostly coming from the geographical. Just there were people who just really wanted copper in London, who just couldn't really have it, or a lot of the copper was.
Oh, like actual copper futures with delivery chain.
Yeah.
Like
as well as
yes. Okay. Yes.
different types of
But that's natural, right? Because those are different products, right?
Of course.
It's like Libyan oil was more valuable in 1970 than Middle Eastern oil because you couldn't get through the Suez Canal.
Which is very analogous to like different configurations in these different gateways.
Yes.
Okay.
Well, I mean, like once again, like these are permissionless gateways.
Yeah.
If you are talking about like, you want if you want your prover to only run in a certain geographically isolated area, which is actually very possible, right? Let's say I don't know this, you're a US-based ZK rollup, and it's really important that only US citizens are generating proofs for you for some reason. Well, then you're probably going to pay a higher cost for your proofs. But that's a natural property of the market, right?
Of course.
I want to thank you, Ismael.
Of course.